What we're looking at here is a diverter valve with an automatic motor actuator, switch to control the movements, and powered to accommodate the 24-volt AC necessary. Let's look at the operation and then we'll look at the component parts. The left switch for my connections turns on the transformer. The right switch is on up, on down, which when I push it down, the valve starts to turn. And it was in the closed position here, and it's opening up so that the water can come from the other side towards the camera, or from the camera towards the other side. It doesn't really matter. It can be configured in many different ways. And so here on the other side, I'm going to flip it again. So I'm flipping it up to get it to rotate. And here it's rotating, closing off the valve on the side and coming straight through. So now what we have is a Jandy three-way valve. This particular one is a 2.5 and 3-inch valve. What that means is the outside connection accommodates a 3-inch coupling, which will fit right over it and glued on. This is a PVC, more specifically a CPVC body, not an ABS. Just because it's black does not make it an ABS material. This black coupling I'm holding is an ABS material. These are two incompatible products unless you get the glue that's very specific to glue PVC to ABS. Using straight ABS glue will not work, will not make the connection to the PVC, and using PVC primer with ABS will destroy the ABS and not work well with the PVC. So be aware of the glue types. There is a difference. So on the outside is a 3-inch connection for a coupling, and then you can reduce or increase your piping, whatever your function is. And on the inside, if I were a 2.5-inch pipe, I would slide in here as if it were the coupling and glue it inside there. That gives you a smaller diameter and less water flow. But if that size of piping suits your needs, that's fine. Jandy does make smaller valves, so you can look them up. At the top we have an Automatic Actuator. Jandy and other brands also make similar products. I chose this one. This one is a 24-volt AC actuator. 24-volt ACs. Make sure that you don't try to use a car battery for DC current. This is straight AC. It gets its power from this transformer. This transformer in this particular case is a Honeywell transformer. It's 120 volts coming in. These two wires are connected and come with the transformer, and then the transformer has two screw lugs to connect the 24-volt AC current, which then provides power. This is the cable that comes with the actuator. It's very long and generous to power the actuator. I have two switches connected. The left one, I choose to power the transformer. Right now it's in the down off position. There's no power to the transformer. Now this transformer is the same as a doorbell transformer. It can always be on, and then when the button or a switch activates it, whatever's connected to it will function. I choose to turn it off because I won't be using this function very often, and that reduces the amount of heat going through the transformer, and even though the voltage is ever so slight, any amount of voltage can be reduced, can be by turning it off. So when I flip the switch up on the left, it's on, the transformer is on, the 24 volts AC is on, going to the switch, ready to command the actuator. The switch on the right is an on position. There's no center position, and you want to avoid a 3-position switch because then there's never a mistake. When the transformer is on and I want to change the position of the valve, I flip it down. It starts to actuate, it starts to turn the valve, and the water gets diverted through the valve in a different direction. Now my main supply of water coming through this valve is straight through the T. You always want your main supply straight through the T because there's less resistance. Whether it's suction, pressure, or gravity flow, your fluid will always flow in a straight line better than turning. Any turn or bend will create resistance or slow down the rate of flow. The handle, which comes with the valve, once the actuator is installed, can then be installed on top of the actuator. It can only be positioned one way. It will not fit anywhere else. Each one of these splines are a different size, so when the handle goes on, this is the closed position of the flapper inside the valve, so you can always at a glance see what position it's in. Now I'm going to change the actuation, the position of the valve, and as it's rotating, you can see that it's moving, and the valve inside is moving with the handle. Now the question comes up is, why do I have power to the valve actuator and the actuator stops? Well, inside the actuator are limit switches. Limit switches are just like your windshield wipers on your car. When it rotates around and you turn your windshield off, the windshield wiper will continue to operate until it retracts itself, and then it shuts the power off. Inside the windshield wiper mechanism and inside this actuator valve is what's called a limit switch. A limit switch limits the amount of time that the power stays on. My two fingers are together and the power is going through the fingers. As soon as the valve turns around to a certain position, there's a cam inside that physically lifts my finger, lifts the contact away from each other, and the power is off. Yes, there's power to my finger and my thumb, as there is inside the actuator, but the power cannot accomplish anything without being connected. So now the only choice that the windshield wiper or this actuator has is to go in the other direction. The windshield wiper already retracted and closed to the bottom of your window. You now turn your windshield wiper back on. We now activate this valve actuator and it starts to turn back in the other direction. The contacts are together. The valve is opening on the inside and closing the other direction. It reaches the cam and it stops. So that's what we have there. So the connections here is important that this is an example of the assembly. This is not the final wiring. The transformer is metal, and on swimming pools or anywhere else, anything metal needs to be grounded. You connect your green ground wire onto a grounding system, and you're safely grounded. You bond all of your metal parts together. If this were a metal box, you would have another jumper lead going from the metal box to the transformer to the ground system. Bonding connects metal parts together. The final wire grounds them to a grounding system. They're similar but a little different because only one wire actually performs the ground. Break that ground wire and nothing is protected. So it's most important that they're all linked together.